Okay, solving an inequality again. This one is different. Do you notice what's this one's got that none of our previous examples have had? It doesn't have a zero on the right, and that's actually a big deal. We need a zero because we can't invoke the zero product theorem otherwise. There's no such thing as a unity product theorem. So before we do anything else, we've got to fix that 1. And how do we do that? Well, you can just subtract it over to the other side, for starters. 2x plus 6 minus 1 is less than 0. Okay, now we've got the 0 that we need so badly. And what we do with this 1, in this case, is get a common denominator for it. Instead of 1, this is going to look a little complex when I first do it. We have x minus 4 over 2x plus 6 minus, and instead of 1, I'm going to write 2x plus 6 over 2x plus 6. Why on earth would I do that? Because I want to combine these two fractions into a single fraction. And when I do that, I get, let's see, x minus 2x is going to be negative x. Minus 4 minus 6 is minus 10, all over 2x plus 6 is less than 0. Okay. Now we've got an inequality that has a 0 on one side, just one fraction over here. This is good stuff. We can now carry on and do the rest of our steps, which would be, well, factor this, which isn't going to produce anything too exciting. We can take a 2 out of the denominator. Nothing all that big, less than 0. And now we look for what we're calling critical numbers or critical values, which are any place that this function is either 0 or undefined. So from the numerator, we get x could be negative 10. Out of this thing, negative 10 is one of our critical values, because if x is negative 10, we get 10 take away 10 is 0. Another issue is if x is negative 3, then we get division by 0, and that makes this thing undefined. So critical values at minus 10 and 3. We put those on a number line, and then we'll see what they do to the behavior of our inequality. So minus 10, minus 3. We're going to look exactly at those values, and we're going to look between them. There we go. And the pieces we have to worry about are our minus x minus 10. I wish I'd factored a negative 1 out of that. You know what? I'm going to do that. If we take a minus 1 out of here, we get minus 1 x plus 10 over 2x plus 3. That's better. Now that we have that, that doesn't change what our critical numbers are, but it means for pieces that we have to look at in this expression, we have minus 1, we have x plus 10, we have 2. You remember in the previous example, we had a positive number like this, and I said we could leave it out. I'll do it one last time. I'll keep the 2 in, and you'll see how little difference it makes. And then we have our x plus 3. So we'll look at the signs of all those pieces, and when we're done all that, then we'll look at the total effect of doing minus 1 times x plus 10 over 2 times x plus 3. And from that, we'll see if we have any solutions or not. So, negative 1 is a constant, and it's negative everywhere. That was easy. If x plus 10, if x is lower than negative 10, we get, say, negative 11 plus 10, negative. If x is exactly negative 10, we get 0. If x is anything between negative 10 and negative 3, then we get a positive number here, and positive again, and positive again. 2 is a positive constant. It's positive everywhere. If x is lower than negative 10, lower than negative 10, we get negative here, negative here, negative here. If x is exactly negative 3, then this term comes out to 0. And if x is negative 2 or higher, then we get a positive result from this piece. So, overall effect. Here we get Negative times negative over positive times negative. That's positive over negative is negative overall. I'll do the solution part at the end. For now, we'll just say that this is overall negative. Here we get negative times 0 over positive times negative. That comes out to 0. Negative times positive over positive times negative. That's negative over negative, which is actually plus. Negative times positive over positive times 0 is undefined. Zeros in the denominator are death, so as soon as you see one of those, you're undefined at that point. And here we get negative times positive over positive times positive, which comes out negative. Good. So what we wanted from all this was for our inequality, or sorry, our expression here, to be less than 0, meaning we want it to be negative. So as far as solution goes, this is part of our solution, up to negative 10. 0 is no good. Positive's no good. Undefined is no good. And then this negative here is also part of our solution. So we get solution up to negative 10, from minus infinity up to negative 10. And we also get solution above negative 3. So not at negative 3, but anything above it. So same drill as before with the sign table. The new thing was if your inequality does not have a 0 on one side, you have to obtain a 0, and that means manipulate the formula, combine fractions if you can. As soon as you've got this 0, we need that because the signs here only tell you when you're changing from negative to positive and back, which means when you're crossing through 0. This property with the table doesn't work with any number except 0.